All right. So we're gonna review today. Again, you said you want to do 1.5. Okay.
Yes, ma'am.
Which one?
Number 4.
Number 4. So this one right here. Okay, number 4. To determine whether f of x approach to infinity or negative infinity as x approach to -2 from the left and from the right of the function f of x equal to secant pi x over 4. So we need to look at -2. So I need to look at this number right here. -2. Are you with me? All right, and then now what do I need to do? I need to look at to the right and look at to the left. So this is your right, and this is what? Negative. So I have two graphs that you need to look at it. This is positive part. This is your negative part. Okay, this is a 2 to the negative. This is what? 2 to the positive. -2, I'm sorry, that's negative in the front. Are you following me?
Yes, ma'am.
Looking at that, can you tell me? The positive side.
Ma'am.
When you're looking at the -2, x approach to -2, where's the graph goes? Does the graph go to the infinity or does it go to the negative infinity?
Negative.
Looking at the positive side.
Oh, the positive side is going up. So
Right. So blue, right? So when you're looking at the positive side, that would be what?
infinity.
Infinity.
Oh, I get that. Like, I didn't know like what secant pi x over 4 was. So it's already dead.
Yeah, this graph is that graph.
Okay.
Secant, okay, secant is simply means, secant theta means, okay, it's 1 over cosine theta. That's what that means.
Okay.
So that's a part of the trigonometry function. So if you graph this, that's what you get here. And the other one should be what? Negative infinity. And you're going to probably say, does it have a limit? X approaches -2. You're going to say what? Does not exist because they don't meet together, right? One goes up and one goes down, so they don't meet each other.
Okay.
All right. Number 5. I'm doing on number 5. Number 5, determine whether the graph of the function has a vertical asymptote or a removable discontinuity at x equal to -3. And this is graph the function using a graphing calculator utility to confirm your answer. So you can graph this. How are you going to put in your calculator? So you can use, of course, you can use a Julia, or if you don't have Julia set up yet, then you can use what? GeoGebra. Because GeoGebra is a free. So you can use that too. So I'm going to do this one algebraically first. Okay, and then we can also graph this, and we can do this numerically. We can do we got 3 different ways you can do: numerically, analytically, graphically. We can find whether it has discontinuity, and if it does, it's a removable or it's just asymptote. So looking at this, I'm gonna do analytically first. Okay, so I would do algebraically. So I'm gonna do f of x is equal to x squared minus 9 over x plus 3. So let's factor the numerator. When you factor the numerator, that's the same as x plus 3 and x minus 3. Okay? So when you factor x squared minus 9, it's the same as x plus 3, x minus 9. So as you can see, it has at x equal to -3, x equal to -3, you have removable discontinuity, because that and that can cancel out. But you also have to say x cannot be what? -3. So you will not have a 0 in the denominator. So this graph is actually same as just simply x equal to -3. That's why you have graph right here. Okay, so since it's that, then you know what to do. So x equal to when you plug it in, you don't have a y value at x equal to -3, but you do have a limit at x approach to -3. So if I ask you to find f of -3, you're gonna say does not exist, but you do have a limit x approach to -3 of this function. Then you have which one? So it'll be x minus 3, you plug in -3, so you have a -6. So this case, you're gonna say removable discontinuity because there's only one spot is missing. At x equal to -3, you have right here, there's a discontinuity, which is -6. You got all the graph is continuous everywhere except x equal to -3. Are you following me, DABN? Is that what you asked me about?
Yes, ma'am.
So this is all algebraically you can do this way. Let's say you decide to use well, they gave you a graph right here, so you can see the graph. Okay, it looks like that. And then if you're gonna put that in your calculator or a GeoGebra, let me see. Here's a GeoGebra. I'm gonna start my calculator. I can graph. Graph. Y equal to, I'm gonna do parentheses. What was my function? Does anybody remember? It was x what? X,
X squared minus 9 over x plus 3.
x squared minus 9 and divided by, there was x minus, x plus.
Yes, ma'am. X plus 3.
That's what I had, excuse me. Okay, so I can graph that. Okay, this is what your graph looks like. All right, then you're gonna ask, I wanna know what is, this is not that good because I like to, if you want to see a graph, you know that's what it looks like. But a lot of time I like to use Julia. The reason is Julia, I can just plug it in numbers, easily calculate like here. If I want to find f of -3 or f of like 2, I'm not really sure how to do it because like looking at my thing, it doesn't really show me easily do it. So you can probably look into this if you want to use GeoGebra, but graph, that's what the graph looks like. And then say -3, you want to know about the -3. So I'm thinking -3 right here, right there. That's why I'm going to have a circle. You're going to have a circle. So limit of x approach to -3 of this function would be -6. but you do not have f of -3 because it's an open circle. Whenever it's open circle, that's a removable discontinuity. Okay, you can remove that discontinuity by applying at one point that you need. Okay, and then when it's not a removable, okay, like this case. So if I give you problems like that, okay, if I have a problems like this, I give you f of x equal to say 1 of x. Okay, it is non-removable because x, if I plug in x equal to 0, what happened? You get 1 over 0, isn't it? Which means what? It's undefined. And then I will have asymptote. Okay, that's a vertical asymptote. So you're gonna have x equal to 0 is your vertical asymptote. Okay, in this case, you're gonna say it is not removable discontinuity. It's just discontinuity. Okay, you cannot just supply at one point and it works. So this graph looks like that. Okay, that's your f. So this case, you have a vertical asymptote. You do not have removable discontinuity, but you have an asymptote, which is discontinuous entire the line of that, not just the one point is missing. If it's one point is missing, it's called removable discontinuity. All right. All right, we can go back to our problem. Okay, number 7. For a quantity of gas at a constant temperature, the pressure P is inverse proportional to the volume V. So this is what your graph looks like. Okay, now it's asking you, let me see. Okay, so it's asking you, now what is the limit of a P as V approach to 0 from the right? So we're gonna say this is a 0 right here. So they're asking you, where does your graph approach to? They're asking you 0 to the right is this way, 0 to the left is over here. So what happened to my graph? Where does my graph approach to?
The positive infinity.
And explain what is the means in the context of the problem. As the volume of gas decreases, the pressure is what? This is your pressure. Pressure is going this way. This is a positive, means increasing this way. That means volume is increasing this way. So when volume is decreases, okay, because over here, this is a low volume, this is a high volume. This is a low pressure, this is a high pressure. All right, so going up means high pressure. Going right is a high volume. So over here, being close to 0 means what? Over here is low volume and is what? High pressure. So when the pressure increases, what happened to your volume? It reduces. Because think about it. The pressure is a pressure down. It's pressing, so you don't have your volume gets to shrink. And then look at this one. When pressure is low, what happened to your volume? Volume increases. Because you don't have any pressure, then And then gas can just go everywhere. So that's why volume increases. So that's why physics, calculus is important. Like this is actually a physics problem that you will see in your physics class. They're talking about in terms of pressure and volume. How does pressure affect the volume? They're inverse to each other. If the pressure goes up, volume goes down. If volume goes up, then pressure what? Pressure goes down. They're inverse of each other. All right. Did I answer your question, Thomas?
Yes, ma'am, you did.
Number one, use the graph to determine the limit. If an answer does not exist, enter D and E. All right, let's look at this graph. We're gonna look at from, all right, C. They told you C is 8, so I need to look at this number right here. C is 8. So this is what I'm looking at. So draw this line. I'm gonna say this is a positive and this is what? Negative. So this is 8 to the positive, this is what? 8 to the negative. Okay, are you with me? So as x approaches to 8, x approaches to positive 8, x approaches to positive to the negative side. So looking at this, so this is my right, where this one approach to, what number does it approach to? Somebody tell me, where's this y value approach to at x goes to 8? 4, that's right, because I see right there, my y value is what? 4. Now let's look at from the left-hand side. Where's my left-hand side approach to? What number, what is my y value? Again, what? Isn't it 4? So I have a left-hand side approach to 4. My right-hand side approach to 4. So what can you tell me? Do I have the limit? What is my the limit? 4. Because your left-hand side and your right-hand side, they all approach to what number? 4, y equal to 4. So when x approach to 8, the limit approach to 4 from the right-hand side to the left-hand side. All right, so it's asking you, is the function continuous at x equal to 8? Yes, because it's what? It's a solid. So that means yes, it is continuous, so yes. In this case, it is a continuous function. It does have a limit. Okay, any other questions? And then make sure that you all say I'm here, so I know everybody's here who are here. All right, let's look at this one. Use the graph to determine the limit. If answer does not exist, enter D and E. So we're gonna do again. Let's look at it. What is their C they were looking at? What's the X they're looking at? This number, -3. So I'm gonna draw myself a line so I know which one is right and which one is left. So I'm gonna do -3 to the right. X approach that limit that I'm looking for, which is this one right here. So where does my y value approach to? Where does the limit approach to? It's -3, isn't it, right there? Right? How about the other way? I'm looking for -3 approach from the negative side. The x approach -3 from negative side of the limit of that function. I'm looking at this side now. So where does also approach to? That's also approach the same y value, which is -2 also. All right, so it'll be -2, -2. So since left-hand side limit and the right-hand side limit is the same, we have the limit, which is -3. In this case, again, this is a solid. So that means we do have a y value. So it is continuous. All right, let's look at anything else. Okay, what about this one? Okay, everybody see this is not a continuous function, right? Does everybody agree? Why is this not a continuous function? Somebody tell me, why is this not a continuous function?
Because the circle is open, right?
What? The circle, open circle means that y value is not, does not exist, right? This is a good problem. So this case, you're gonna say this is discontinuous function, and this is what? Removable discontinuous function. Why is it removable? If I supply one value, if I just supply one value right there, does it become a continuous? Yes. So this kind of function, you can say removable discontinuous function. Okay, because I can just apply that. But for now, so what is my function now? Let's look at the limit. I'm looking at the limit right here. This is the limit that I am looking at. So I'm going to look at to the right. This is my right. Limit x approach to -4 from the right hand side of this function. What is that equal to? That is equal to 4. The y value is goes to 4. Okay, y value is not 4. It's the limit is approach to 4. Are you with me, class? The y value does not exist because this is a circle. But limit is approach to 4. All right, next one. Let's look at the other end, the left-hand side. Left-hand side of the limit. So x approach to -4 from the negative side of the limit of this function. That's still what? 4. All right, so I have a right-hand side 4, left-hand side 4. So I have a limit which is equal to 4. So my limit is 4. Limit x approach to 4 of this function is 4. Now, class, then what is my value at x equal to 4? I mean -4. Okay. What is my value x equal to -4? Can somebody tell me, look at the graph and tell me what is y value at x equal to -4?
It does not exist.
Okay. That part does not exist, but do you see any other point in this graph? Where do you see a solid point? I see a one solid point. Okay, Shalia?
It's 6.
6, right, it's a 6. Because I see right here, they gave me a 1 point, but that 1 point is not here, but 1 point they gave me is over there, which is what? 6. It says when -4 and x approach to -4, I mean, and when x equal to -4, y value is what? 6. So this means right here means x equal to -4. When x is -4, y value is 6. That's what that means right there. Over here, this is your limit in this case. All right, so because 4 is not equal to 6, that's why it's what? That function is what? Discontinuous. Because limit is not same as what? The value. When limit and the limit value is not same as y value, then this is discontinuous. So this is classic discontinuous, I mean the removable discontinuous function. There's only 1 point is missing, but that 1 point is happen to be way above here, not over here. That's why it's discontinuous. So this is a very good problem. So let's moving on to another one. What about this one? Can you tell right away this is discontinuous function for sure? Okay, what about the limit? Okay, I want to know the limit at x equal to 4. I'm just going to draw my line here. So positive side, the limit x approach to 4 from the positive side of this function. Can tell me which one do I need to look at it? Bottom graph or top graph?
Top graph.
Is that the right or left? Okay, I'm asking you, do I need to look at this one? Do I need to look at this one? Number 1 or number 2 for the right hand side?
Number 1.
What is it?
Number 1.
Okay, number 1 is your left. Look at this. Look at this line over here, Stephanie. This is my line. Which side is a positive? That's a positive, isn't it? Positive is right. Which one is right? There's a graph. To the right is right, isn't it? So this is right. What is this one? That's your left. So I need to look at this bottom graph for my right. So I'm looking at this graph. Where does this y, where's this limit approach to? Limit is approach to which number? -4. So this is a -4. Are you guys following me? Okay, Stephanie, are you with me now?
Yes, I am.
Okay, they give you a line, they tell you what x to you look at it. They told you to look at c equal to 4. So you look at the 4, you draw a line yourself, and anything to the right of their line is a positive side of the limit. So anything to the line to the left is what? Left is your negative side of your limit of that x approach to. So now I'm going to look at the next one. I want to look at the limit x approach to 4 from the negative side of this function, which means I need to look at this graph. Where does this one approach to? +4. All right, so looking at that, because my right hand side and my left hand side is not same, I do not have a the limit. It does not exist because -4 is not same as +4. They're not meeting together. If they meet together, you have the limit. If they don't meet like this, okay, that means what? It does not exist. You don't have a the limit. You have a one side limit, you have a one side limit, but not the limit. Okay, since it doesn't have a limit, and you know what, okay, let me ask you one more thing. Can somebody tell me what is f of 4? What is a value at 4? X equal to 4. What's y value when x equal to 4? Look at the graph and tell me what's that equal to.
It's 4.
It's 4. That's right. Because this is what? Solid. That means that y value is included. So it's equal to 4. Not -4, right? Because -4 has what? Open circle, which means that y value is missing. But this is a very good problem too. Okay. All right. Okay, this is what I mean by non-removable. This graph, when you graph that graph, okay, the graph looks like that. Because if you plug it in 0 as your denominator, what happened? It's undefined. So you have asymptote. When you have asymptote, you call it non-removable. The discontinuity is not removable. It's just discontinuous. Because you cannot just supply one point and make a connect. You cannot connect them. They're just completely separated. All right, 7, the same section 4?
Yes, ma'am.
Okay, so we have this. Okay, well, this is a good problem too. Very good. Okay. So this one I can rewrite, I can factor this. You get a x, you get a 1 minus x, 1 plus x. Because 1 minus x squared, when you factor that, that's the same as 1 minus x, 1 plus x. So I have a 2 asymptote. So I can say 1 minus x equal to 0, which is what? X equal to 1. And then 1 plus x equal to 0, which means what? X equal to what? Negative 1. So I have a 2 asymptote. So when I graph, I will have asymptote here and asymptote over here. The reason is I cannot cancel them out. I don't have anything in numerator to cancel this thing out. If I cancel out, that become a removable discontinuity. All right. In this case, I cannot cancel it. So that means that would become an asymptote. Whenever your denominator become a 0, that x value become your vertical asymptote. So you have a 2 vertical asymptote. X equal to 1 and x equal to negative 1. So these two are, because of those two, they are non-removable. If it's asymptote, it's a non-removable. Okay, I want just to make sure that you understand between the non-removable and removable discontinuous. So if I give you this graph, this function, I give you this function. All right, can you tell me which two x I cannot use? There's 2 values that I cannot use because they will make denominator equal to 0. Okay, let's factor this. When you factor this, it makes sense. So if I factor this, so x squared minus 9 is the same as what? X plus 3 and x minus 3. Just factor this quickly. You do x and positive 3 and then what? Negative 3. That give you that number. Because x times x give you x squared, positive 3 times negative 3 give you what? Negative 9. So that's what you have. So you know x cannot be 3 and x cannot be what? Negative 3, because this give you what? That make denominator equal to 0, which makes what? Which become undefined. All right, but look at this one. One of them is a vertical asymptote. The other one is removable discontinuity. Can somebody tell me which one is going to be which x? X equal to 3 and x equal to negative 3. So which one is asymptote and which one is removable discontinuity, and why? Can somebody tell me? One of this x would be a asymptote, or the other one would be removable point, discontinuity point.
So the asymptote one gonna be the first one, which is x equals 3, because when you plug in 3,
Right. That's exactly right. Thank you. Very right. Very right. Very, very good. Because this and that can cancel out. That means this x equal to negative 3 is what? Removable discontinuity. Because if I rewrite this problem now, I get a 1 over what? X minus 3. So this right here, okay, this, I cannot do anything about it. That just become a what? Asymptote. So when I graph mine, okay, that's what you get, asymptote. Then I will have a graph here, and I will have a graph over here. But I'm gonna have a what? 1 point. So I will plug it in. I will plug it in -3 here, and I get a 1 over -3 minus -3, -6. So at -3, I will have need a circle. This is what your graph looks like. So this is a good problem. So you know which one is asymptote, which one is what? The removable discontinuity point. Does it make sense to you, class? Okay. So just think about this graph, this problem. One is removable, one is non-removable. The non-removable become a asymptote. The removable point become a just a what? Circle. All right, so you have an exam next Tuesday. So next Tuesday, you can come to a room at 2:10 and you can take your exam, or you can take your exam in a Zoom. That is fine, because everybody has to show your face. And when you take your exam, like what you're doing right now with me, some of you guys not showing your face. The day of exam, you have to show your face, so I can see you taking your exam. Okay, so that's how I'm gonna proctor you.